Okay. Sorry, just doing some tests, getting everything up and running. I made some major changes to my streaming software setup, so I'm just checking everything out, making sure everything is gonna run as planned. Cool. It's good to go. It's doing a final system check. We will get started in like just a minute. I know some people have mentioned before that the resolution was that we were streaming in really low resolution. It looks like on my end we have like other resolution settings available. I just checked that out. Go ahead and play around with those if you feel so inclined. Let me know how the quality is at the end of the stream. It looks like I was in like 720 and it looks a bit grainy, so might be some adjustments still necessary, but hopefully this will mark an improvement on the quality, the graphic quality of previous streams. Cool. So last time we had left off on removing dictionary keys. I think I just had one more challenge to get through here. Yeah, it just looks like the last one. We do have a question, actually. We're starting off today with a question, which is nice. The question is, can I touch on putting multiple methods together? Example, a function that takes a string, adds the indices of each string, of each instance of a vowel to a dictionary. Okay, we have some example code here. I'll just paste in the whole thing. Oops. No, I don't want that. No, don't do that. Must have some add-on that I wasn't aware of. Okay. All right. So I think the question, could I touch on putting multiple methods together? Letter IDX. So it looks like this has a context, perhaps from learn, that isn't clear in the question. I'll do my best to infer what this is based on this input and output. Should be enough for me to reconstruct this behavior, but I might have to take some creative, have a little creative license with how I interpret this. If this question is from Learn, just put a link in it so we'll have a little additional context. So when I read this, can I touch on putting multiple methods together? I'm thinking about like chaining methods. Example that takes a function that takes a string, adds the indices of each instance of a vowel to a dictionary. Okay, so every time, oh yeah, okay. So I think I do remember this. I think I helped somebody recently with this particular problem in Learn. Okay, so it looks like, let's just def letter IDX takes in text and returns. I'm just gonna do an empty dictionary. Oops, and return D. Okay. So, oh, where's my output? This is not. Interesting. We got a bunch of tools up here. Okay. Okay, there's my empty dictionary. So, am I correct in interpreting this? E occurs at 1, 8, and 10. O, so there's only E and O in here. Those are the only vowels. So so it finds vowels, and then it puts those vowels as the keys in the dictionary, and it puts their indices, all instances of the indices, in a list at the key of that vowel. Okay, so index 1, that's true. 2, 3, 7, 8, 10. Okay, good. 2, 3, 4. Good. Okay. So this question being in the context of, can I touch on putting multiple methods together? Like chaining, and like I said, I'm assuming this means like chaining methods together. I can touch on that. I'm not sure how to do it in this particular context. But I will do my best. So, if let's just see here. The way I would do this is just for character in text, if character in, and then I'm going to do c dot lower. Actually, I don't really care if it's upper or lower. You know what? Actually, I'll just do text dot lower. And then I have all lowercase c's, because I think that's all that's going to matter anyways. So if the character is a member of, and I'll just do a string of vowels, A, E, I, O, U. Let me try that again, A, E, I, O, U. Okay. So if the character is a vowel, if character not in D dot keys, then we'll say D sub character equals empty list. Now that we know that there's an empty list that resides at D sub character, whatever that character's name is, D sub E or D sub O in this case, we will D sub character dot append the IDX, which means, of course, I need the IDX to append. So we'll enumerate. Okay. So this should produce that result. All right. Let me just okay. So this is how I would go about solving this particular problem. In terms of touching on how to put multiple methods together. I mean, we are using several methods here. We're using lower and d.keys. We're using a list.append. So we've got a string method and a dictionary method and a list method here. But in terms of like using them together, this this solution obviously doesn't use any chains of methods, and I can't think of any right now. There may be some way to like, I'm sure there's a way of consolidating this and making this. We could do this on one line. We could do this as a dictionary comprehension actually, but for the sake of simplicity, this will do. So let's see. Yeah. I can demonstrate something along the lines of putting multiple methods together, and we'll just do that separately. I'll just do this in a separate section. So I think, and I apologize if you could confirm that if that's what you're asking, that would help me out. But and I think this is what you're asking, so I'm just going to answer this question. It's an interesting question, and I'm sure it'll help some of you all out. The thing about, so we'll just call this chaining methods, right? So this is sort of a trivial idea, but there's a really important there's an important underlying mechanic of the way that Python works that kind of is the interesting part, in my opinion. When I say this is trivial, I will hear people asking, and I'm like I said, I hope that that's what the OP is asking here. I will hear people ask me like, how do you know how to chain methods together? Because it looks kind of fancy and it looks kind of flashy, but as soon as you understand what's going on, it's very straightforward. So this essentially has to do with what different functions and methods and expressions evaluate to, right? So and when I say what, I mean when I say what they evaluate to, the what means not only their value but their type. And really the type is the important part for this particular discussion. But number one, understanding that expressions, functions, and methods do evaluate to some value. That value has a type, and that type likely has methods associated with it. So let's do an example here. I'll talk, in order to get at this, I'll talk about expressions first. So expressions. So 3 plus 8 is an expression that reduces to 11, right? So 3 plus 8 is an expression that reduces to 11, and I could even say 3 plus 8, which equals 11, is equal to 11, which itself, this whole thing is an expression, right? So we have this expression built out of actually two other complete expressions, right? One of those expressions itself is built out of two more complete expressions. And if we look at 3 and 8 and 11, these are themselves expressions that express literally what you see. They express themselves, right? So 8 is an expression that, surprise, surprise, expresses the integer value 8. Oh, cool. Thanks for that link. I'll get to that. Yeah, so this expresses the integer value 8. This expresses the integer value 3, right? When you see some piece of code that expresses a value that expresses literally what you see, we call that a literal, right? So this is an integer literal that expresses the literal value 11. It expresses what you see. Okay, so it's not hard to see that, and we could change this equality sign. Let's do a little math here. So 11 times 11, it's what, 120? Oh, I don't know. 11 times 9 is 99. Cool. So let's do this. Oops. So 9 expresses 9, 3 expresses 3, 8 expresses 8. 3 plus 8 expresses 11. 11 times 9 expresses 99. This expresses 99. So the whole thing reduces down to 99. So it's not that hard to look at this and say, well, in those parentheses, we're just asking for that to evaluate and then produce some number. And I'm using this very, I hope, very accessible, simple, straightforward example with sort of a trivial, unimportant, simple math problem to illustrate this idea of expression, which I'm kind of pointing at right here, right? So you have something that's made of some parts that evaluates to something else. Let's look at another thing that fits that description, which is this, right? So this is every bit as much an expression as this. So these two are both expressions. 3 plus 8 expresses an integer. Letter IDX, hello there, expresses a dictionary. So in either case, we can look at code like this, even though there's sort of a visually, like they look like different things, but these are both expressions in that this is made of some parts, right? It's made of 3 and 8 and an operation, which is a plus. And so it's made of these constituent parts that can be reduced via some process to the value that they express, right? So in this case, 3 and 8 are the inputs to the addition operation, which expresses the sum of those two numbers. In the case of letter IDX, it only has one input, which is the string hello there, and via some process, which I just wrote right here, right, reduces this, quote, reduces this input to a dictionary, right? So we take in our input and we get a dictionary on the output. So this expresses a dictionary every bit as much as this expresses a value, right? And we could even kind of give an intermediate step, right? We could do def, I'll do this down here, def add nums, take in a and b, and return a plus b. No big surprises here. So if I do add nums 3 and 8, this is every bit as equal to the expression 3 plus 8. And they're not only equal because they produce the same value, but I mean they do it in the same way. Add nums is just an abstraction over the other one. But the important thing here is if I use 3 plus 8 in the middle of some code to do some math, it's the same as using add nums in the same place, right? So let's go back to our simple expression here, our simple equation, right? I can use 3 plus 8 here like this, or I could times 9 like that. right? And these are equivalent expressions. And I'm just putting space in between just to show the, I don't know, just to kind of justify things, line them and make them a little prettier, but the spaces aren't necessary. So hopefully this is clear. And I want to really, really establish this idea of a function call giving back a value in exactly the same way as just, you know, doing some math operation that reduces down to the result of that operation, right? You can think about it, 3 plus 8 is an operation. The plus sign is an operator. You could think about add nums as an operator, right? It happens to do exactly the same thing, right? Another way to think about it that's sort of the inverse of that is add nums is a function that takes inputs and expresses a value. It's a prefix function, meaning that we prefix the inputs with the function name, right? We say function name, then the inputs. And then you could also look at, and it's a little bit incorrect in Python to look at it this way, but you could also look at the plus operator as a function, as an infix function that goes in between its inputs, right? So it's just a matter of the order the things go in, but they are doing the same thing. Okay, cool. So I think that idea is established well enough, and apologies if that if I'm just kind of harping on the same thing and you get it. But I just want to make sure that idea of a function expressing a value and, you know, different groups, different parts of your code expressing, giving back values is well established in order to answer this chaining methods question. So, chaining methods. Let's just do this. Chaining methods. So this is something that I remember when I first started programming, I would see a method or 2 or 3 chained after an initial method call, and it just like would blow my mind because it looked complicated beyond all reasonable reckoning, and it just seemed unfathomable. But one day, it was the moment essentially that I realized whenever I saw a function call, I could just think about wherever that call is, and I mean the call, not the definition. So wherever I saw a function invocation, a function call, I had the epiphany at one point, oh, I should just see that function call as whatever value and type that it returns, right? So when I see add nums 3 and 8, I don't see this weird function call thingy. I see 11 because I know what add nums does, and I know what its inputs are, and I know given those inputs it should give me back the integer value 11. So it should give me back an integer with the value 11. Okay, so as soon as I really grokked that, something like chaining methods was just trivia. It was just like, oh, a method call, and I'm showing this with a function, but it applies to most method calls, or the method calls that that we can chain together. It applies to those. So let's see. Let's think of something to chain together. We could okay. We could do, let's have a string, and just for the sake of consistency, let's just reuse this string. Hello there. Hello there dot count e. So here's a method call. Now, in order to understand chaining methods, look at this method call. I feel like Yoda when I say this. It sounds, I feel so cheesy, but It's like look through the method call into the thing that it returns, right? So if you're familiar with count, you probably know this. You probably kind of know this. So I'll give you a second to think about this. What does count return? So strings have this method, and lists and tuples also have this method called count. Count takes in an argument, which is an element that may or may not be in the string or the collection that you're calling it on. In this case, it's a string. And oops, that's the variable e, which we don't have in scope. I need to pass it the string e so it knows to count how many e's there are, right? So what kind of data type would represent a count? Right? If I wanted to count, if I wanted to know the number of times e showed up in my string, like a dictionary would probably not be the right data type to represent that information. An integer seems much more up to the task, right? So count returns an integer that represents the count of its argument in the thing it's being called on, right? So in this specific case, this is going to give me an integer of e. Cool. Right, and let's say, I don't know, let's give this an English accent here. We'll say, hello there, like this. Okay, so I'm wondering, I'm like looking at this and I'm like, why am I getting a dictionary? Because I'm not printing it out. So let's just capture this in res for result, and we'll print res. I could also just print this directly instead of assigning it to res, like print like this, but I don't know, I usually do things like this, but I'm just trying to like mix it up a little bit. So we're capturing the result in res and then printing the result, right? So if I want to know how many e's were in this string of hello there, I could do string.count e, and then I get 2 e's. But we can see there's obviously there's a third character that we would consider an e. It's just an uppercase e. I can't do counts of multiple things really here, but what I can do is I could say dot lower, right? Dot lower returns a lowercase version of the string. So this is going to essentially turn this string into this. But I'll leave it that way. So this gives me a lowercase version of the string, and then I can count e's in that string. Just to chase this idea of an expression, let's look at this. We'll make this, initial expression a little more complicated, and we'll still see it's an expression. We'll say, hello there. How are you? So you can see we added an extra e right here at the end of R, right? So, so this whole thing expresses an integer. After this whole thing in parentheses here evaluates, we get an integer, right? So here I could even continue it further. Everything up till this point gave me a string, and then count gave me an integer. So notice this concatenation expression gives me a concatenated string. Dot lower is a method on strings that returns a lowercase version of the string. Dot count is a method on strings that returns an integer, right? So since dot lower returned a string, I can call dot count on it because it's a string method. And since dot count returns an integer, I can call an integer on it. And since everything in these big parentheses here is whatever this whole expression gives me back, I could call the integer method here, or I could call it here. And just to mix things up, I'll call it here. So I don't find myself using that many integer methods, so I kind of tend to forget them. So we'll start an IPython 3 terminal session, and let's do dir int like this, and we'll see the directory for ints. So we've got a few integer methods. As integer ratio, bit length. That's interesting. Image, interesting. Real, 2 byte. Let's try 2 byte. Now I'm just kind of exploring different methods. Oops. Int has no attribute 2 byte. 2 bytes with an S on the end. Okay, let's try that. 2 bytes takes arguments. Dang. Okay. Missing required argument. Okay, so let's do help on int dot 2 bytes. I think I did this exact same thing a few weeks ago on this exact same method in study hall. I'm having this deja vu feeling. Okay. So it returns an array of bytes representing an integer. Length, byte order. Wow. Okay. Takes a few. Takes in length, byte order, and then some number of arguments. And okay. So byte order is probably going to be big and little. Okay. Yeah. So this is endianness, which is a whole other thing, but we'll just pass in something there. And then length is so length of bytes, object to use, an overflow error is raised if the length is not representable with the given number of bytes. Okay, cool. So I think a small integer is going to be a 4-byte integer by default. So I don't know. Let's just do 5 and see if there's kind of a tail at the end. And we'll do little. Or actually, we'll do big because that's more intuitive. Okay. Let's see what we get there. Yep. Okay, so 0, 4, which is the value. That's the count of how many E's there are. This is written in hexadecimal. And if I let's just arbitrarily put some more E's in here. We should have 8, right? 0, 8, 9, 10, 11, 12, 13, 14, 15. So that's F. And then 16 is going to move that F to 1 over there. So we're dealing with a hexadecimal type here. So, but yeah. Anyways, we're kind of going off the rails. This is becoming more about how the 2 bytes method works. I probably should have chose a different one, but whatever. So hopefully this is clear, whether or not it's clear, like specifically what the output we're seeing is or what 2 bytes does. I know this is kind of a weird one, but hopefully it's clear that this method chaining is based on what expression, what type, what data type is being expressed at every stage, right? So this first part here, we concatenate a few strings together, and that expresses that string, that concatenated, fully formed concatenated version of that string. Then we want to count all the E's. So before we count, we're going to dot lower just to make sure we standardize any capitalized E's, and then we'll count all the dot lowercase or all the lowercase E's. Count gives us an integer, which means we can do integer methods, and then we can keep chaining methods from there. Cool. All right. Cool. Hopefully, I know I kind of went off the rails on that one. It was a little bit, I wasn't totally clear on what was being asked there. This is a question that I get enough, so I'm hoping maybe this would apply to a couple of you, or this would be helpful for a couple of you. But yeah, I think that idea, I think it's one of those kind of central ideas, particularly that idea about expression, right? Once you realize that, once you realize what you're seeing isn't the function call, it's the thing the function call or the method call expresses. Once you really grok that, a whole lot of things like chaining methods together just becomes obvious, right? Cool. And we do have a link for that other problem. Let me grab that and throw it in Learn real quick here. Third problem here. I'm just going to see if my solution ended up working. I think this is kind of off topic for what we've been, for the how the question was asked before. Let me blow that up a little bit. Maybe we can do one more. And let's pull Chrome over just a little bit. Sorry, I'm just trying to move this around so there's enough window there. Okay, that's pretty good. Oh, awesome. Glad that was helpful. Let's see what I got. Oh, I got the wrong result. All right, so let's see. So write a function called letter IDX that will track the indices of where the vowels occur in a string. This function should take a word or a sentence as an argument. It should be case insensitive. So this should be case insensitive, which means I actually need to do my dot lower. Oh wait, insensitive. Be case insensitive means treat a lowercase a the same as uppercase a. Okay, which is what I'm doing here. Return a dictionary with the keys that represent the vowels that occur in the sentence, and the values representing the indices where that vowel occurs in the word. Well, I sure thought that's what I did there, but all right. Well, let's see what the error had to say. It says these are not equal, and I can already tell that y, and that probably, yeah, okay, so for this exercise, the letter y is considered a vowel, so I have to include y in here. All right. Okay, good. Cool. And then somebody asked me if I could explain the code that I wrote in detail. I assume that this is regarding letter IDX. Do you still want me to do that? Just let me know. Say if you can just say yes, please explain it. I think there's like a 30-second or a minute delay after I changed the resolution stuff. So if you just tell me yes, please explain it, or no, you're good. Then I'll know what to do. Till I get an answer on that, I'm going to move on to the next question. Trying to solve this problem, I was trying to use, I see. I see. Okay, so this is some context actually on the original question. Whoops. Okay, so it says, in trying to solve the above problem, I was trying to use multiple methods like update with index or append with index. Yeah. I see why that could be confusing. And gosh, I should have mentioned this actually. So if we, oh, okay, and then this actually, let's try this. Let's see, so 4. So presumably you had a dictionary like this, and I'll just reconstruct the whole function. Okay. So this should replace probably that first bit there, and I'll just clear out everything else. New dict equals a dictionary. And I'm actually just gonna call this D because that's what I like to do. In lower string, this is text. And I think what you did was something like lower string equals text dot lower, something like that. I'll usually end up just overwriting. With something like this, I'll just overwrite it like that, but let's see. Text equals text dot lower. Yeah, I'll just do this dot lower here. Oh, no, sorry, it doesn't need to be like that because we're using it twice. So, just to touch on the way that you're doing this, dot index will always give you the first index of I. The argument to update, this is a little weird. The argument to update is a dictionary, and it's a dictionary method. Right now, this is going to give us an error because, let's see, I think we need to actually call it in order for the error to occur. Okay. Now, well, that's interesting. Huh. If I equals, let's do this. If I in A-E-I-O-U-Y. Okay, this is what I was expecting. So we had to be able to successfully activate this line of code in order to get the A, right? It's going to say key error, letter A. Yeah, basically this is saying that's not a key in the dictionary. Because it thinks you're trying to call a method on whatever value is located at this key, and there isn't a value located at that key. There's nowhere where you said like letter A is a list of integers or whatever. So it's kind of a weird one. So anyways, so dot update is a method on dictionaries directly. I think what you'd want to do is something like this, and then you could, so dot index is a weird one. So anytime you're trying to learn a new method, I'll show you how to go about figuring it out. I like to start an IPython session like this and just kind of have it running. Sometimes I'll have it side by side with my output or whatever. In Replit, you just have an IPython session just running that you can just type in whatever, so you can just type in the terminal in Replit if that's what you're using. And you saw me use dir before, and help. So in this case, I want to get help on index, and I'm using it on a string, so I'll do just string or str, whatever. We'll just do string like this. Doesn't have to have anything in it. It can also have something in it. Oops. Help. Help on string dot index, and then we'll cap it off right there. So notice I do not put the parentheses after index because I don't want to invoke index. If I try to do this, it'll give me an error and it'll say index returns an argument, but I don't actually want to do that. Or excuse me, the error says index takes an argument as an input. But I don't want to give it an argument. I don't want to invoke it. I just want to pass the uninvoked version because I want help on that function, right? So this will tell me let's just copy this in. When you find yourself in this window, by the way to get out of it is you just hit the Q key, and that'll get out of it like that. Okay, so here's your help text. Help on built-in function index, method of built-in string instance. And this is meant to show you kind of how it works. So I actually didn't know the argument was that complicated. I just thought it would just be an object or something. So we can check for the index, the starting index of some sub is presumably for substring, and then it can take a start and an end slice, I guess, which is kind of interesting. Yeah. Cool. So this is the important part. This is the part why I called the help function. If this is confusing, we can just ignore it for now. The important part here is this, where it says return the lowest index where S is the, I shouldn't have deleted that, S right here, where S, excuse me, return the lowest index in S where substring, called sub, is found, the lowest index, right? So that's kind of the weird thing about the index method. It seems like it's going to be really useful. If you know, if you have an element and you want to know the first index in which it occurs, you can use the index method. But that's all. That's the only thing it's good for. So this won't get you all the indices, unfortunately. So in order to do this, we have to do enumerate. Oops. Excuse me. So for I in enumerate text, and I'll call this IDX, and then we would do something like, oh, I hate using the dot update method. I just never find it useful, and I don't know if it's me. I don't know if it's me or what. This is not going to work, I don't think. Unhashable type list. Oops. There we go. So this will actually, yeah, it's not quite going to work. So again, actually I would just do what I did before. I'm just turning this into, I was trying to like do it with the tools that you were using, but This is the way that makes sense for me to do it. So, anyways, I don't know, I just turned it back into my solution. Sorry. But yeah. So something I should mention just to wrap this this particular question up. Update, if you were trying to chain a method against update or append, these actually don't have a return. Well, it's kind of weird. They return the value none. So let's just look at that. Let's say list equals a list, and then I can say list, it's an empty list, list dot append hello. I don't know if this will actually do this. Doesn't show me the result. So if I try to, I actually have to print this out. So if I print it out, you can see the result is none. So the value returned by list.append is none. I don't think none even has any methods. But regardless of whether none has methods or not, if you were going to chain a method after an append, you're probably expecting the append to return the list, which it doesn't. So you just have to do the append on its own line and then do list dot whatever other thing you wanted to chain onto it that way. Now I'm curious. Dir, let's see the dir of none. Yeah, there's no regular methods. It's all just dunder methods and stuff. Cool. Okay. Awesome. That was fun. I like it when I kind of get it into the nitty-gritty things, talking about the like how expressions evaluate and stuff. It's fundamental, but it really gets at the core of how the language works, which I find to be fun. I don't know, but yeah. Cool. So I'm not seeing any other questions at the moment, which is fine. So I think we'll just move forward. We'll move forward with the material. All right, so we had this last removing dictionary keys question. So just quick recap on this. We talked about two tools for removing something. We talked about pop and Dell. In either case, you have to know the key that you want to remove. It'll remove that key and the value associated with it. Since you can't have an orphaned key or an orphaned value, i.e. you can't have a key without a value and you can't have a value without a key in a dictionary, it'll just remove the pair, the key value pair. So pop, let's have a dictionary. I'll just use this dictionary. So we'll call this sum D equals this dictionary, print sum D. We'll do pop up here. And then we'll say sum D dot pop E. I must make them regular. Okay, there we go. I feel better. Okay, so if I pop E, or let's try to pop O. So if I pop whichever key, it's going to remove that key value pair, right? Okay. So let's try this with Dell. Oh, I neglected to mention something important about pop. So wherever you call pop, oops, um, wherever you call pop, the line where you call it returns whatever value was at that key that you popped, right? So we pop on O, or here, let's pop on E actually. Let's pop E. And, oops. We'll just call this res for result. Res equals that, and we'll print res as well. Okay, so you can see, here, let's do this. No. Okay, so that'll just label them in the terminal there. All right, so sumd has both of its key value pairs. Then we pop and we print res, which we captured from the pop. And then sumd, you can see, has been mutated by the pop. Dell Okay, so Dell works like this. Dell is a keyword. It's not a function or a method. There aren't a whole lot of keywords in Python, and keywords tend not to do things that uh, methods or functions also do, right? So it's a little bit of an outlier because, you know, pop kind of does this job, and del is not a function or a method. It's a keyword. So def or for or in context are all keywords, things like that. They're just like special built-in words that Python gives special meaning to. So del just deletes whatever you tell it to delete, whatever you put after it on its right-hand side. So if I tell it to delete this dictionary key, it'll delete that dictionary key. I can't capture a result. I think this will be an error actually. Yeah, so I can't even do that. It's not even valid code. It doesn't even return none. Cool. Okay, cool. So that's the recap for what we talked about with removing dictionary keys. Actually, let's do this. Okay. Well, come on. Oh, all right. Write a function, blah, blah, blah. Okay, so write a function called delete dupes. Take a dictionary, takes a dictionary as an argument. Function should go through the values inside the dictionary and remove any key value pairs where the value occurs more than once inside the dictionary. Okay. We got a question here. Could you tell it deleted the value or only the key? Oh, yeah. Hey, let's go back and look at that real quick. Cool. So if we look at the output here, right, and I'm deleting E, if we look at this output, here's our before, and here, I'll do this here. Here's our after, right? So in this case, I'm deleting E, and the key and the value for E have gone away in the after, right? So after I delete, E and its value are all gone. Does that make sense? Cool. There's such a delay. I can't really. I want to wait for people's responses, but I can't really. It'll just be me sitting here waiting. A lot of crickets in the background if I do that. Unfortunately. But do let me know if that helps. Okay. Write a function called delete dupes that takes the dictionary as an argument. The function should go through the values inside the dictionary and remove the key value pairs. Okay. Where the value occurs more than once inside the dictionary. This function should remove the second occurrence and the third or fourth, not the first. Okay. We can think about this. This is in the remove section, but I'm going to do this. I'm going to do this in an easier way that doesn't involve using remove. What the function's called this print delete dups. We'll take in some D, and oh god, I don't want to make a dictionary, but okay, whatever. Some D equals so some D equals, let's say, A, B, C, D, E. And we'll just do some integer here. Oops. So we'll say 3, 4, 3, 5, 7, 9. Okay. Okay. So we've got some dictionary with some kind of arbitrary data here, and I should have. Oh god, I wish I had like ordered this, but let's see. We've got 2 3s. We've got 2 4s. I think those are only duplicated elements here. So our output should be equal to let's make another instance of 3 here. So we got 3, 3, and 3. So we're going to keep the first one, and then we're going to get rid of all the following versions. And then we've got 4 and 4, and we're going to get rid of the latter version. Okay, so we should have A, B, C, F, H. A, B, C, F, H. Whew, okay. I know this I always think when I do this kind of thing, I always think, you know, I could see uh, I could see somebody like watching this going, okay, I'll just kind of wait through the whatever this phase is until I get into the code. But like, um, it is important to test things out. It's important to write some good tests. Um, if you don't, then it's like, how do you know what you did uh, is going to work? How do you know it's going to do what you intended it to do? I'll just do this. Okay. So it's important to put in that time up front. That way, you don't have to, like, the step of verifying what this thing is supposed to do is already done, and then now all I've got to do is make it do this, right? Presuming that this is the amount of tests that I've written is exhaustive, meaning it tests everything that needs to be tested. In this case, I think this is fine. One test is usually all you need, sometimes 2 or 3, but okay. So delete dups, we'll take in D. I'm going to call this dn. So I said I would do this in an easier way that doesn't involve removing at all. I'm just going to do a regular accumulator, return D, regular additive positive style accumulator. That meaning we start with an empty dictionary, we start with something, an empty accumulation target, and then we just add in the correct values. So for this, we can say for kv in d in dot items if d in dot count v is greater than 1, right? So, excuse me, if dn dot values, here's a method chain. So dn dot values, I don't know if I can actually count on dot values. I'll try it. I think that's going to give me an error, but I'm pretty sure I'm going to have to cast this to a list in order for count to work, but I'll just try this for now. It'd be kind of nice if it works that way. So if the count of v in values is greater than 1, actually, I'll do this. If it's less than 2, and I actually don't want to do, I don't want to do dn, I want to do d. Oh, now that makes it so easy. I don't need to do any of this. I can just say if v not in d dot values. So if v is not a value in d dot values, then d sub k equals v. Yep, that's it. So we're not using remove at all. Oops. But this should still work. Something like that. It's kind of funny. Okay, let's just try this. Oh, and I should I should do the last step, which is check, right? So I expect A, B, C, F, H. We get A, B, C, F, G, H. Ooh. So it looks like we did 7. Oh, somehow I must have deleted G by accident. A. I don't see another 7 in here. Okay, so I guess I just G. Not that this matters. Okay, whatever. Okay, that works. So, oops. Oh, gosh, I hate it when I do this. I do this like all the time. I like accidentally right click and then click back on the in Chrome. You can't see my right click menu, but okay. Anyways. So let's actually do this in the way that it was probably intended. This is not the way it was intended, but we'll do that. And then, yeah. So the way it was likely intended was to use use the remove method. So first thing, I'll just copy D back into the same namespace. That way I don't even have access to the original, so there's no danger of mutating the input. Everything after this first line in the function, D is a different object that just happens to have the same values as the input. So I've copied it, duplicating its footprint in memory, but I'm not gonna. This is gonna save me from accidentally altering something outside of the function. Which again, Python will let you do that, but it's something you should avoid. Cool. So in this case, I'm still gonna return D. I'm still going to do for kv in d.items. We'll change that from d to n to d. And then in here, this is where I'll need to do count. I'll need to count in values. Oops. Dot count. And like I said, I don't think I can call dot count on dot values because it doesn't return a list. But I'm going to try it out anyways. So if this is So I do need to know if a given value occurs more than once. And if it does, I want to add it in, or I want to skip it the first time, but I want to remove all of the next occurrences of it, which is kind of weird because dictionaries don't have an order. So I think this problem, they're like ordered enough that this problem will still work. So let's call this, let's have a scene vals list equals empty list. So if d dot values dot count v, then we want to, at some point we're going to d sub k, or we're just going to del d sub k if it occurs more than once. So if it's greater than 1, so if d.values.count value, so if the count of the value occurs in values more than once, right, we're going to delete d sub k. We're going to do this under a different condition, though, and I haven't quite figured out what that one is. I think we're going to delete it, yeah, if v in scene vals list. Then we're going to delete it, else we're going to add it into scene vals list. And this will mean, that, okay, the first time we encounter it, encounter a value that occurs more than once, we'll say if d.values.countv is greater than 1, in other words, if, I'll just rewrite this, if v occurs more than once. So if v occurs more than once in d.values, it's kind of implied, but whatever. Then we say if the value is in the seen vals list, then we delete it. And since the very first time we encounter it, it's not in there, we're going to add it in. We're going to do this else. Maybe it might read easier if it was like this. If v not in seen vals list, then add it in. Otherwise, it is in there, which means we're going to delete it. And this mechanism is sort of a latch that allows us to go in and add it in the first time we see it, which means we don't delete it. And then if it's already added in, we do delete it. So this, in either case, either way I had it written, it's going to skip deleting it the first time that we encounter it. Whew. All right, let's run this again. Yeah, so this is the error that I was expecting. So it says dict values object has no attribute count. So I do need to cast this as a list first. Not surprising. I could cast it as a tuple as well. Dictionary changed size during iteration, because of course it did. So I could copy it again. Instead, I'm going to do dn again like this. Dn. And then we'll actually iterate through dn like this. So this is actually a really interesting error. When you try to reduce the size of something that you're iterating through, I'm going to take a second to explain this error, because this is a really interesting error. I'll just, oops. I'll do it actually in a different context here, because I'll do it with a list, so it's a little clearer. Yeah. We focus in on one thing at a time. Let's see if that's going to work. Okay, so this works too. I prefer this code. I mean, look how just simple and vanilla that is. And I mean vanilla is a good thing. It's nice to have code that just kind of looks and works like a lot of other things. To me, this looks like so many functions. Empty, obvious accumulator target up at the top, couple lines of looping and conditions, simple add in the value under the right condition, iterate through the thing, return after you're done, right? Versus this, which is a bit of a monstrosity. But yeah, let's see what the original suggestion is. It looks like it's something, looks like a little cleaner. Yeah, it's a bit cleaner than mine. Okay. I'll get back to that error because I want to explain that error as well. So def delete dups takes past dict. Return dict is a copy. Occur list, so this looks like my scene list. If pairs in past dict.items, this code won't actually run because they're doing .items, so they need to do two things here, so whatever. Oh wait, no, this will run, but it's just weird because you could do k comma v instead of pairs like this, but essentially pairs sub 0 is going to be k and pairs sub 1 is going to be v. It's a little bit dense the way that's written. So if pairs sub 1, if key, if value not in the occurs list, then we add it in. Else we delete it. Oh, and that's actually a good point. We could just add in everything, and then if we see it again, it's already been seen, so we can just delete it. So I can actually trim this because I don't need this first condition here, which is kind of interesting. This is just superfluous. I worked hard for that condition too. I didn't even need it. Okay, cool. So that's a little more optimal. Still, I think I like the first solution better. Okay, cool. All right, I want to explain this error that I got because it's a really weird one, and it gets at something that's pretty interesting. So this is a runtime error. You don't get a lot of runtime errors. This will be the last thing for the day. We're basically at the usual time where I wrap up. So I'll go over this and we'll wrap up after this. Runtime error, dictionary changed size during iteration. And this will happen with a list as well. So imagine let's say I have a list equal to okay, and I'll just say for element in list if L is greater than 5, I want to list dot pop, or actually do, yeah, list dot pop L. This will help a little bit. Oh no. I can't believe that worked. That was supposed to give me a runtime error. Dot remove. Is it only for dictionaries? Oh my gosh. Well, alright, shows what I know. Is that okay? I guess I have to learn more about that error. Maybe it only applies to dictionaries. I feel like I'm just doing something slightly different here. That's so funny. Okay. Maybe it's Dell that triggers it. List sub I. Oh my gosh. Okay, well, we're not getting an error, but we're certainly not getting the expected behavior. So this is supposed to remove all the elements greater than 5. You can see we have 8 here and whatnot. So this is still still proving my point. This kind of behavior is exactly why this is why I'm so confused. Why I'm not getting a runtime error, because this runtime error exists to prevent exactly this behavior. It would be more desirable that I was getting a runtime error, not only because I wanted to talk about the runtime error, but because look, I mean, this says if L is greater than 5, delete that element, right? And you can see we have an 8 in here. I think this is going to occur if we have multiple elements that are greater than 5 consecutively. Oh, interesting. Oh, that's because we had that. Okay. Yeah, so there's a 9. Yep. So this is an interesting thing, and I'm frankly flabbergasted that this is the kind of thing that high level language like Python, and Python in particular is really good at sort of sheltering you from with these really nice errors that help you not do things like this. So if you think about this, after a while, when we delete an element, right, our I value is going to advance, but essentially what that means is since we deleted something, the element to which our I value refers to now no longer reflects the next element. It reflects two elements further along. So yeah, initially we're going to come to this 7. I'll do this on a copy here. We're going to come to the 7, right? So index 0, index 1, then we're going to delete lists of 1, and then it's going to move on to index 2, right? The index value is going to be 2. Well, index 2 refers to 3, so there was never in this operation, there was never an index that referred to 8, right? We never had an opportunity to refer to this 8. So we'll look at 3, then we'll look at 7. So we're on index 2, 3, we'll delete this. 4, right? So we skipped that 5. So I'll just put a little hash over all the ones we skipped. 4, 0, 1, 2, 3, 4, 5. So we'll delete this one. We skipped this one as well. We're going to move on to 6 and then 7. And we'll just delete this one. Yeah. So that's what we're going to end up with. And you can see that's what we get. So I don't know why on earth it's not throwing this runtime error, because the point of this runtime error is to make sure that this doesn't happen. So anyways, it's interesting. This runtime error is interesting, and it's even more interesting that evidently sometimes it doesn't happen. Maybe truly it really only does happen with dictionaries and not lists. But anyways, cool. We'll wrap up on that little mystery. If you all can figure out like how to make this code produce a runtime error, where I went wrong, it's probably something really obvious. Play around and see if you can get that runtime error to throw. It's a little added challenge. Yeah. And if you figure out what's going on there, feel free to DM me and put it in the chat. I will do the same if I figure that out as well. All right. Cool. This is a good place to wrap up. It's been fun. Thanks for the folks who had questions today. Seemed like a lot of pretty good interaction for the last study halls. Seems like they have been a little slow, but we've always had a question or two. Do let me know. Send me a direct message. Let me know how the streaming quality is, how the audio quality is. I tried to do some run my audio through a noise filter. Hopefully that's cutting out some of the background noise. I know that was an issue. I do have a small fan on my desk here. It's not pointed at the mic, but you might be hearing a little from that. But yeah, let me know if the streaming quality was better or worse, if it was choppy or if it was good, if the resolution was coming through all right. I'll be happy. And just any other feedback that you have, I'll be happy to take that under consideration. Cool. Yep. We'll wrap up there. And I'll see you, if you're in Premium Prep, I'll see you tonight. I'm teaching tonight. And if not, then I'll see you on Wednesday for next study hall. Cool. Bye-bye.